This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video I'm going to be going through some other points of note to do with parallel lines and perpendicular lines in coordinate geometry. So the first 2 points we need to make is that if a question ever states that a line cuts the x-axis or cuts the y-axis, we have to let y equal 0 if we talk about cutting the x-axis, or let x equal 0 if we talk about cutting the y-axis. We can see this if we just draw our x and our y-axes. So our x and our y. And if we have any line, then if we look at the point where it cuts the x-axis here, we see that the y value is at 0. And if we talk about where it cuts the y-axis, which is here, then we can see that our x value, our value along this line here, is at 0. Then, if we ever talk about the point of intersection of two lines, what we're really looking for there is to do simultaneous equations, and there'll be an example of this in another video. But the big topic we want to cover here is the idea of parallel lines and perpendicular lines. So all these points down along here. If two lines are parallel, that means that their slopes are going to be equal. So if m1 is the slope of one line and m2 is the slope of the other, then we want m1 to be equal to m2. If we want to prove that two lines are perpendicular, what we need to show is that m1 times m2 is equal to minus 1. And of course, just recall that perpendicular lines just means that the two lines are at right angles to each other. So this angle here is a right angle, or 90 degrees. Then, if we were to look at the actual equations for the lines, if you are, say, given the equation of a line ax plus by plus c equals 0, where a, b, and c are numbers that are given, then the equation of a parallel line will always be of the form ax plus by plus d equals 0. So what that means is we have two lines that have the same slope but cut the y-axis at two different points. So if we draw our axes here, our x and y axes, x and y, and we have two lines, say here and here, that are parallel. In order for them to have the same slope, we need to have a and b to be the same number in both cases, because you remember that if you have ax plus by plus c equals 0, the slope is equal to minus a, the number in front of x, divided by b, the number in front of y. So if two lines are parallel, their slopes need to be the same, so we need to have a and b be the same two numbers in both cases. The only thing that will be different is that constant at the end, the c or the d, because if you look at this picture here, these lines cross the y-axis at two different points. If they were to cross at the same point, they would just end up being the same line. Next, if we're to look at perpendicular lines, if you're given the equation of a line, ax plus by plus c equals 0, and asked to write down a line which is perpendicular, you need to write down a line which has equation that looks like bx minus ay plus d equals 0. So what we've done there is we have swapped a and b, and then change sign in front of y. The reason we do that is because of our equation that we had up above, that we want to have m1 times m2 being equal to minus 1. So if we look at the two equations that we have here, these two equations over here, we can see that we have ax plus by plus c equals 0, and that means our slope there is going to be equal to minus the number in front of x, a, over the number in front of y, b. But then if we look at our second equation, bx minus ay plus d equals 0, our slope is equal to minus the number in front of x, which is b, over the number in front of y, which is minus a. Now when we have a minus divided by a minus, that ends up being a plus, so our slope in that case is going to be equal to b over a. So if we take these two slopes of minus a over b and b over a and multiply them, then we will get minus a over b multiplied by a b over an a, which is equal to minus ab over ab, which is minus 1, the result that we wanted up here. We have a minus 1.